welcome back to my channel. Today we'll be going over the topic of complex numbers. So, before we get started, don't forget to smash the subscribe button and hit the bell icon if you want to know everything there is to know about complex numbers and math. So let's jump straight into it. So before we get started, we have to learn about the definition of complex numbers. So the definition of a complex number is a number of the form a plus bi, where a and b are real numbers and I is a square root of -1. Okay, with the definition in mind, let's move on to an example. So this example states 6 minus the square root of -48 divided by 2. So before we get started with canceling out the 6's and the 2's, we first have to deal with the square root of -48. So how do we solve this problem? So we have the square root of -48. So the square root of -48 can be broken down into the square root of 48 times the square root of -1. Am I correct? Yes. So what do we do with this? Well, we can go ahead and rewrite this as the square root of 48i. And why is that, you ask? Because in the previous definition that we went over, it said that I is equal to the square root of -1. So with this in mind, this is basically equal to I. So that's why we can derive -48 into 48, the square root of 48 times I. And if we are to further simplify this, we can see that the square root of 48 is equal to the square root of 16 times the square root of 3. And what is the square root of 16? Well, we have to multiply it by I too. What is the square root of 16? Well, the square root of 16 is just 4. So we can get the answer as 4 square root 3, and then outside of the square root, I. So now that we have that, we can just rewrite this as, we can rewrite this problem right here as 6 minus, and then we could put our answer that we got right here into the above fraction, which would be 4 square root 3i, and then all this over 2. And then if we were to simplify this, we would just do the simplification. We would get 2 divided by 6, 3. And if we were to write this in standard form, we would get 3 minus 4 square root of 3i. Okay, hopefully that makes sense. And just a quick consideration when coming to this form right here, this is called the standard form of a complex number. So standard form. This is called a standard form of a complex number. And then as we went over, a and b are the imaginary parts. And also an important thing to remember as part of complex numbers is that I squared, if we were just to take this I squared, that would just be equal to -1. Because if we were to put I squared here, then this root would cancel out and we get I squared is equal to -1. So this is also an important thing to remember right here. Okay, keeping that in mind, we solved this, we got our answer right here. Let's move on to another example. So this example is called I to the power of 2017. Whoa, that's a big number, isn't it? Well, I have a completely easy solution that should make this easy for you. So I have a little table that I would recommend memorizing. So the table is, if we just go, I'm gonna have to draw this. So we could write the table as I to the power of n is equal to 1, comma, we'll put I right here, comma, we'll put -1 right here, and we'll put -I right here. So you might be thinking, why do I have this written right here? Well, if we continue on, we can see that n mod 4 is equal to 0. Right here we'll write n mod 4 is equal to 1. N mod 4 is equal to 2, and n mod 4 is equal to 3. Okay, so what this is, so what I mean by mod right here is what I basically mean by, if we were just to write, what does this mod mean right here? Well, that mod is basically just saying the remainder of n divided by 4. So let's use this table that I created and let's do it. So as you can see here, I we have is corresponding with I. But what is n? N in hours right here, this is n. N is 2017 in hours. Problem. So if we were to find I to the power of 2017, we need to find the remainder of 2017 when it is divided by 4. Since 2017 divided by 4, so we'll just go ahead and do the long division. 2017 divided by 4, and we could put 5 minus 20, 0, 0. Well, here we could put 4 minus 16, we get 1. So our remainder is 1. So that means it's n mod 4 is equal to 1. So where in our table does that show? Well, if we look, it shows right here. It shows right there. N mod 4 is equal to 1. And what is the answer that it's showing us? The answer for n mod 4 is equal to I. So what this basically means is that this entire question, I to the power of 2017, is equal to I. And we're done. That's our answer. As simple as that. It just takes a little bit of effort to memorize this table all right here. But if you memorize that, that will be the easiest thing. Okay, let's move on to another example. Okay, here we have a little bit of more of a complex problem. Here we have 3 plus 4i times 3 minus 4i. So here we could go about using the FOIL method, which is first, outer, inner, last. But if we notice here, we can see that the complex numbers, the only thing that they're different by is the plus sign and the negative sign right here. That's the only thing there's a difference in the plus sign and the minus sign. So how do we go about this? Well, if you remember one of your formulas that you learned in algebra, the formula says that x, let's write this right here. We could use the formula. I'll just write formula. So the formula is x plus y times x minus y is equal to x squared minus y squared. So as you can see, this basically fits the requirements for this. The only thing that's different here is the signs, and that's the exact thing that is required in the formula. So we could set x as, so if we just go here, we could set x is equal to 3 and y is equal to 4i. So that works. So if we were to use this formula right here, we would get 3 squared minus 4i squared, 3 squared minus 4i squared, which is equal to 9 minus 16i squared. Remember that this is one giant, this is just one giant term. 4i is just a term. This is a term, and we're squaring it. That's why we get 16i squared. And if you remember from the previous pages where we learned about the definition, we learned that I squared is equal to -1. So I squared is equal to -1. So we go on to our next problem. We can see that we have I squared here. So I squared is equal to -1. So what do? We can just go 9 minus 16. So minus 16 times -1. And what would be negative 16 times -1? Well, we would get 9 plus 16. And that would be our answer of 25. And that is our answer. And we are done. How easy was that? Complex numbers might seem like a complicated topic, but once you understand what is I and how complex numbers work, it's going to be a piece of cake. Okay, so let's move on to conjugate of complex numbers. So we have to also learn the definition of a conjugate of a complex number. So the definition of the conjugate of a complex number is basically like a converse of it, like the inverse or a converse, you could say. So a plus bi and a minus bi. So the difference here is the sign again. That's the only difference in these two. So if we go back to our example right here, we can see that these technically are conjugates. These technically are conjugates. These technically are conjugates of complex numbers. So now that we have the definition in mind, let's move on. Now you may be asking, the division. Well, why are complex numbers even useful? Well, if we understand something, so if we have 2 plus, then we have 3i, and then we multiply it with the conjugate, we do 2 plus, minus 3i. Well, if you notice in our previous examples that we had right here, this resulted in a real number. And so if we were to expand and do the same thing that we just did, we would, which is the same property, which is the x plus y times x minus y, you get x squared minus y squared. If we were to do the same property for here, we would get 2 squared. Let me write it in a different color. You'd get 2 squared, and then we would get minus 3i squared. So if we were to do this and multiply all this out, we would get 13, because 4 and then -1 times -3, which is plus 3, and then squared, so 9, and then we would get 4 plus 9 is 13. So that's how we would get 13. So no matter what we do with the conjugate of a complex number multiplied with a complex number, we will always get a real solution. So conjugate, or well, complex, and then we'll do multiplied. Let me do it in a different color. Multiplied with a conjugate is always equal to real number. Then we'll just put a hashtag for number. So this is very important to remember. Oh, whoops. This is very important to remember. So with all of that in mind, we have also some theorems related to the complex and conjugates of numbers. So the theorem is, if we were to have z, we'll just say z stands for a complex number, so we'll say z is equal to basically a plus bi, which is the standard form, a plus bi. We'll just say z equals a plus bi. So if we were to do z times z, and then this symbol is known for the this symbol over the z, it's called a conjugate symbol. So it represents a conjugate. So if we were to multiply these out, we would get, here we would get a plus bi, and then we would do times a minus bi. So the theorem of this is called, well, it's not called anything. Well, the theorem just states that this would be equal to a squared plus b squared. So that's an important thing to remember. Like just how he said the x squared plus y squared, that's basically what it is. Oh, sorry, not plus. This should be minus. That's too big. We'll go minus. This would be minus b squared. Okay, hopefully that makes sense. Let's move on to the next. So here we have division of complex numbers. Now, in my opinion, division of the complex numbers is one of the hardest parts of complex numbers, but complex numbers in general are pretty easy. So this should be pretty easy too. So if we were to perform the division of this complex number, we begin with rewriting the division problem as a fraction, and then continuing. So how do you write this as a fraction? Well, this is simple. This is the top part and this is the bottom part. So we just put 2 plus 3i over, and then we would do 3 minus I. So this is basically the rewritten form of this question in the fraction form. So the first step to do is always to kind of like rationalize the denominator, I guess. So the first step is to multiply the numerator and the denominator. So basically by 3i, because that's how we rationalize it. So what we would get is we would do 2 plus 3i times 3 plus I. And we would multiply it with plus I, because to get rid of this, to get rid of or rationalize it, we have to multiply it by the conjugate. So we do 3 minus I times 3 plus I. This will always give us a real number, and we always need a real number in our denominator no matter what. That is why we multiply and try to rationalize it out. So if we were to go ahead and simplify this, well, we would just multiply this out, and it would be, I think it would be 6 plus 11i, 11i plus 3i, plus 3i, I think, 3i squared, yeah. And then over all this over 3 squared minus I squared. And if we learned, I squared is basically -1, isn't it? So -1 times, well, this is -1 right here, times a negative right there. That would just give us +1. So if we were to write this, well, we'll write this as step 2. This is technically step 2, which is simplify. So let me write step 2 as simplify. So this is basically simplify. That's basically simplify. And then this is not supposed to be step 2. This is actually step 3. And this step 3 is basically to simplify again. And this is basically to get rid of these i's, and then to just make it more neat. So what this would get us is, if we were to do the denominator, we would get 9 plus 1, like I explained, and we would get 10. And then if we were to do the same with the numerator, we would get, this is 6 plus 11i, and then 3i squared. This would just be, again, -1 times 3, so that would just be 3, -3, so 6 minus -3 is 3 plus 11i. And then we have to rewrite it in standard form like always. That's always how your answer should be accepted by your teacher. Your teachers always want it in the standard form, which is a plus bi and then squared. So how do we write that? We'll write in standard form, and then we will write, this is very simple, we just split it in half, like dot like that. We just split it in half, so we'd get 3 over 10 plus 11i over 10. And we are finished. That is our complete answer. That is our answer. 3 over 10 plus 11 over 10i. Now we'll do another example. So this example we'll do the same. So basically, this is already written in the fraction form for us, so there is no need to do anything. So I would like you to pause the video and try this problem out for yourself. Are you ready? Okay, let's go. So what we have to do here is, remember, like the previous step, we have to multiply with the conjugate of the bottom. So we would do 4 plus 3i parentheses times 2 plus 5i. That's what we do right there. And then the bottom, same thing. We just do 2 minus 5i parentheses times 2 plus 5i. And if we were to multiply and then simplify all this out, we would get 8 plus 26i and then plus 15i. 8 plus 26i plus 15i, and then we have to put squared up there. And then if we were to simplify this out, we would get 4 plus 25, which I'll just write as 29. Or we could just leave it as 4 plus 29, and then we could simplify this in the next step. Okay, next, oh, I forgot to write the 5. Now, next step, step 2. Well, this is step 2. just to multiply. Step 3, again simplify. So step 3, we would just get negative 7 over plus 26i over 29. Remember, I'm just doing this fast just to show you, just to give you a brief overview. If you have any questions, don't hesitate to leave them in the comments. I will gladly go over this problem and then just explain it to you. But here we're just doing 15 times negative 1, and then same thing we just did negative 5 times positive 5, which is 25i squared, negative 25i squared, which is just positive 25, and then 2 plus 2 right here is just 2 times 2 is right there, is just 4. So just like the x squared minus y squared property, that's basically what I just applied here, because there's just a difference in the symbols. Hopefully that makes sense, and then we'll continue. So then step 4, we basically just rewrite this as standard form, which is negative 7 over 29, and then we'll go plus 26i over 29, and that is our final answer. Some people like to write the I here or write the I there. I just like to keep it more simple, like right there. Okay, and that is it for today. So thank you guys so much for watching the video. I really appreciate you if you would like, share, and subscribe. Peace.